Hello and welcome to this lesson on quantitative problem solving and how you'll need to employ technical mathematics to succeed on some of the GMAT problem solving questions. So there are just certain quantitative problems where technical math is going to be the only reasonable tactic. There's no two ways about it. So this is going to require basic arithmetic, algebraic, and geometric skills that really don't go beyond 9th or 10th grade, say, in the United States. Now, these technical math skills are not necessarily associated with high difficulty problems, at least according to the adaptive difficulty function of the GMAT exam. So even though you may have trouble doing some of this technical math, it isn't necessarily the most highly rewarded skill set. So it's one of the things that you want to address early in your GMAT prep if you are struggling with some of the technical mathematics skills in arithmetic, algebra, or geometry required by the exam. Now, strategically, you want to always attempt the technical approach first, because if you can do it, it's probably the fastest approach. But you will also want to prepare yourself to abandon the approach as soon as it ceases to be both apparent and simple to you in the moment. So what apparent means is that you can simply set up the math. Simple means that you can solve the math. So if neither of those things is true, you'll want to abandon the technical approach pretty quickly. You'll also want to note the numbering format in the problem and the choices to inform efficient calculations. So if your answer choices, for instance, are in percents, you'll want to do your manipulations in percents. If they're exponential, you'll want to do exponential manipulation. If they use pi or radical notation, you'll want to do so as well. Do not force yourself to always use, say, decimals if the answer choices are in fractions, or compute fully exponential notation, because you're adding steps that the exam probably won't require. So let's take a look at a sample word problem. So the technical word problem process is going to be similar to all of our other problem solving processes. We're going to first set up the scratch pad, listing the choices vertically from A to E. Then we're going to skip to the end of this problem to identify the sought value and label the choices as such. In this case, we're being asked for the number of minutes it would take Callum to travel 10 miles at the average of Abby's and Barry's rates in terms of A and B. Now, we see that we're looking for the number of minutes for C to travel 10 miles. That's how you'd write it out on your scratch pad. Then we want to read from the beginning, taking notes and setting up equations as we go. So we start by seeing that if Abby travels 4 miles in A minutes and Barry travels 2 miles in B minutes. So we're going to write this out immediately, knowing that our rate is going to be equal to distance over time, and our time is going to be equal to distance over rate. And the average of these two rates is therefore going to be 4 divided by A plus 2 divided by B divided by 2. Then we want to process that fraction. So we have to get a common denominator of AB, and we know that when we get the common denominator of AB, we could just combine that with the divided by 2, and then we'd have to cross multiply up and over to get our new numerator of 4b plus 2a, which is then, of course, all over the denominator of 2ab. Then we want to simplify this fraction. So we know that 4b plus 2a all over 2ab, there are factors of 2 throughout, so we can remove those and get 2b plus a all over ab. Then we want to solve for time, as t is going to be equal to 10 divided by all of this based on our distance over rate formula. So then we just have to take the reciprocal and multiply it to discover that 10ab is going to 10ab over 2b plus a is going to be equal to t, and that is choice E. Again, there are alternative tactics that we can potentially use on a question like this, but they're not going to be as direct and probably as efficient as what you just saw with the algebraic manipulations if it's simple and apparent to you. So let's next take a look at an arithmetic example from technical mathematics. So Again, same process. Set up the scratch pad listing the choices vertically A to E, and this time we'll write out simple numbers in the choices, because remember, that's going to help us note we are dealing with simplifying radicals. I've got radical notation, so that helps me indicate what's happening. And again, note the format of the choices to inform those efficient manipulations as you go. So we're going to have to remove common factors to simplify these roots. So we start by just ignoring the radical symbol and writing out the multiplication distribution that we have of 27 times 10 minus 9 times 5. So we could see that we've got common factors first of 9 in both 27 and 9. So we pull a 9 out of 27, leaving behind 3 times 10. We pull a 9 out of 1, and we leave 1 times 5. Then we can pull out we can process the parentheses. So we've got 9 times 3 times 10, which is 30, minus 1 times 5. So we end up with 9 times 25. And at this point, we're going to put the radical right back in on top. So we've got radical 9 times 25. We will then distribute said radical to discover that 3 times 5 is 15, and our answer is 15 from the technical arithmetic. And note, there really isn't going to be a great way to solve this problem except the technical math. If you don't see how to do this problem technically, recognizing that it's asking for something very specific without any sort of additional information, if you don't feel comfortable manipulating these radicals, it's probably going to be best to logically estimate and move on almost immediately with this problem. And because you can see all of the factors even of 5 and 10 and 3 are throughout the answer choices, unless you're able to do this process the manual arithmetic way, it's going to be very difficult to get correct, and you probably just want to be honest with yourself and say, I'm not making progress, let's move on to the next question. So let's do that now, and we've got a geometry problem solving example. So we've got a figure, we've got a question asking about this diameter of a circle. Same process to start, set up the scratch pad, list out the choices, we'll write out the simple numbers in the choices because they're pretty straightforward. We then skip to the end to identify the sought value. We see that we're being asked for the area of the rectangle inscribed in the circle is what percent of the circle's area. So basically, what percent of the circle is in the rectangle. So we write out the formulas, and we're going to try to avoid drawing the figure if possible. Relatively simple figure here with a rectangle and a circle, with the rectangle inscribed in the circle. I don't want to draw this. It's going to add additional time if I can avoid doing so. So we are going to write out the formulas though, and we know the relevant formulas are going to be area of a rectangle, which of course is L times W, length times width. We also see that the diameter of the circle is going to be the same as the diagonal of the rectangle. So that means that it is equal to 10 because the problem told us so. Excuse me. So we also know that a diagonal squared is going to be equal to L squared plus W squared because we're looking at a right triangle. So we're looking at a Pythagorean integer triple of 6, 8, 10. Because 6 squared, 36, plus 8 squared, 64, is 10 squared, or 100, which now gives us our length and width for the rectangle as 6 and 8. Which means that the area of the rectangle is going to be 6 times 8, which of course is 48, and 48 out of the 100 for the area of the circle, which is going to be pi r squared, is going to be 48%. Again, you can see the technical approach is definitely the fastest. You could potentially logically estimate this based on sight, but again, it's not going to be perfect, and it's really kind of tricky to figure out exactly how everything works unless you know these formulas and recognize something like the Pythagorean integer triple, which tells you, hey, here's a little shortcut if you can recognize some of these things that the test will evaluate frequently. So let's talk about the process we just saw. So step 1, set up the scratch pad, listing the choices vertically A through E. Note specific algebraic expressions or numbers in the choices to help inform your calculation, and note those format of the choices again for that purpose. Then step 2, skip to the end of the problem, label the choices as the sought values. Note if you're seeking a specific or non-specific value, because that can also help you determine whether you want to use technical mathematics as an approach. Because if you're looking for a non-specific value, if it's algebraic, I might want to manipulate for it. If it's a range or something that isn't exactly one arithmetic or algebraic expression, I may prefer logical estimation or another alternative tactic. And you also want to avoid auto-solving for individual values if you're seeking a combined value. Think back to when we were talking about the word problem and the combined rates for Callum. We had no interest in their individual rates, so we just immediately went to solving for the average, and you don't want to waste time solving for individual values if they're seeking a combined one. Step 3, read from the beginning, taking notes and doing obviously needed calculations as you go. Take the technical path to solving, because if you can, it's probably going to be fastest, and you'll abandon that technical approach if at any time it ceases to be both apparent and simple in the moment. So that's our process for technical math in the problem-solving section of the quantitative section of the GMAT. Let's go ahead and head over to the whiteboard now to take a look at a sample problem in the exact same way that you will execute on the test. So let's take a look at an algebraic expression problem that is probably, again, going to require some technical math because they're asking for a very specific value in this problem. So as always, we'll still start out with our answer choices A, B, C, D, E. Put a little line over top for what the value is seeking, or what the problem is seeking, and we've got our answer choices as simple numbers 3, 5, 10, 12, and 25. So we've got our question. We're looking for the value of y is how many times the value of x. So we're looking for the number of times y cubed is of x squared. So we immediately want to go to set up the information as presented. So we are told that x times y is not equal to 0. So that means neither of them are 0, which dictates that they can't just be 0, which would negate everything. And we then see that 3x squared is, so equals, 60%. So that's going to be 0.6 of, so that means multiplication, 20%, so 0.2 of times y cubed. So at this point, it's up to you as an individual to decide how you believe it will be easiest for you personally to manipulate the technical math. You can either do this as a decimal or you can do it as a fraction, but just pick a side because you don't want to have to switch midway. So in this case, I'd probably say that in my estimation, it might be easier as a fraction, just because I can do 6/10 or 3/5 and 2/5 or 1/5 pretty easily. So 3x squared is equal to 3/5 times 1/5 times y cubed. So right now, before I go any further, I can see that everything is going to be multiplied by 5 to solve. So that means I can always be looking to logically eliminate some things. And I'm going to get rid of the pieces that don't have, or the choices that don't have 5 as a factor. So we then just keep on solving, and we'll want to eliminate by multiplying the thing by 25 to eliminate all of our fractions first. So we get rid of 25, and we get 75x squared is equal to 3y cubed. Then we can just divide by our 3 on each side, and we'll have our 25 over here just to make sure we did everything properly. And we've got 25x squared is equal to y cubed. And you can see, again, not the most complex of problems if you do it technically. If you tried to do this using Another tactic, say back solving or plugging in values, you could theoretically accomplish the same goal, but it's going to take you significantly longer to find out that y is 25 times, or sorry, y cubed is 25 times x squared, and that the answer is choice E. So, after having viewed some of these technical math tactics in this lesson, try out some technical math skills and practice problems on your own, and also take the time to refresh on some of the technical math concepts in arithmetic, algebra, and geometry that will be tested as part of the GMAT quantitative exam.